All right, so today we're going to be taking a look at hyperbolas. All right, the equation to a hyperbola is pretty similar to the equation of an ellipse, but there are some minor differences which impact the graph of the equation very, very much. So let's talk about what a hyperbola is. The definition of a hyperbola and an ellipse are pretty similar actually, but basically what we want to do well, I'll just read you the definition, right? So we have a set of points, which would be x and y, and we have where the absolute value of the difference of the distance between the two foci is going to be the same. So once again, we're using the focus to measure a distance, and that distance will be for each of the different pieces of the graph will have that same similar distance. So there's a lot of new vocabulary because we're dealing with a different type of shape. All right, so let's talk about it. So this is what a hyperbola looks like. It's both of the U shapes, right? So it's not that it points up or down, it's that it points both directions. So this right here is one hyperbola. So this part right here, the actual curve, we call them each a branch, right? So a hyperbola has two branches. In this case, one that points up and one that points down. You can see actually over here, sometimes a hyperbola can have branches that open left and right. All right, so there are two different ways that hyperbolas can open. Just like an ellipse also has two different variations, right? It can be long horizontally or it can be long vertically, okay? So because a hyperbola is not a closed shape like an ellipse is, there's only one axis. Instead of having a major or minor axis, we just have the one axis, which if you wanted to basically make, a comparison to an ellipse, what the major axis is in the ellipse is what the transverse axis is in a hyperbola. All right, so the main axis, the one that goes through the center, through the vertex, through the focus, that is now the transverse axis. No, it's no longer the major. We still have a center, okay, and so we still have values like A, B, and C. B is still used, although we don't see it, but I'll be showing you how to use it. So the distance from the center to each vertex, right, so center to here and center to here, that's the A value. The distance from the center to, there's going to be another point that's kind of an invisible point, but it goes along the opposite way of the transverse or perpendicular to the transverse axis. That would be the B value, and like I said, I'll show you that in a bit. But we still have a C value where it's the distance between the center and the focus. All right, so we have a lot of similarities, but we have some different vocabulary, and we have some different, some different variations and things in the formula as well. So let me show you the formulas. All right, so we have two variations. One is when the transverse axis is horizontal, right? So that would be this example. The transverse axis is horizontal. And then we have the second one is when the transverse axis is vertical, just like the one that I was showing you up here. So let's kind of dive in and take a look at their formulas. So you might look at this and think that it's really, really similar to an ellipse, and you're right. We still have x minus h squared, we still have y minus k squared, we still have a squared and b squared. One thing that's different now is that we have minus in the middle, not plus, right? An ellipse has plus in the middle. We still have the equation equal to 1, so that hasn't changed. So the main difference is that we have this minus, but also one of the differences is that our numerators are now changing. So if you think back to ellipses, we sometimes had a squared in the denominator here and b squared here, or sometimes we had b squared first and then a squared. Now what happens is a squared and b squared, they stay put in both of the equations. What changes now is the numerator. All right, so in an ellipse, the denominator was changing. In a hyperbola, the numerator is changing. And the reason that that changes is for us to know what the orientation of the hyperbola is. All right, so a no longer has to be the larger value. A is just under the positive fraction, and B is under the negative fraction. All right. So when your positive fraction has x in the numerator, that means x, the x-axis is the transverse axis. When the positive fraction has y in the numerator, that means the transverse axis is vertical. All right, and so that's how we know the orientation of the hyperbola. So once we start writing things into standard equation, in standard form equation, once we start graphing, these things are going to become a little bit clearer for you.